section 7.3, page 6. We're going to look back at the first example for shells a couple of pages ago, page 4 I believe. And if you look back at that diagram, it's pretty tiny. So we're going to redraw that diagram and make it much bigger. So we have some maneuvering space here. We didn't work through that first one as a shell example because it was a rather difficult shell example to do as the first one. So we're coming back and we're going to pick this one up again. And we have this region here that we've spun about the y-axis. Redrawing this figure and putting the shell in here now. What makes this one difficult is when you draw the sides of the shell, you cannot draw them going down because then you'd be peeling off cylinders of nothingness. So that shell actually has to be drawn going up. There's that shell in there. And let's extend this out or peel this off. Here's this rectangle, this shell that we've peeled off and flattened out, and finding the volume, 2 pi times a bunch of radius times height times thickness. Okay, radius goes from axis of revolution out to the function, which is right here. That is an x value, so we'll put that in here, x. Now height is this distance right here. It is a y value, but it's not strictly y. This distance right there, that's y. So this height is, what was this height at? Oh, this point was 1, 2. So that height is 2 minus y times, and then thickness. How thick is that? That is a dx thickness. Matching our variables here. X is fine. 2 minus y, well, y is this 3x minus x cubed. Watch the signs here. I'm going to clean that up. I'm going to distribute this minus sign through. The 2 minus a 3x plus an x cubed dx. Bounds here, smallest radius to largest radius. My largest radius is out here at 1, smallest all the way down to 0. Then to anti-differentiate here, we'll have to distribute that x through. We have 2x minus 3x squared plus an x to the 4th dx. Anti-differentiate. Let's see, x squared minus x cubed plus 1/5 x to the 5th evaluated from 0 to 1. That's going to be 1 squared minus 1 cubed plus 1/5 times a 1 to the 5th minus 0 into each of those is 0. This gives us a 2 pi times 1 minus 1 that's gone. Here's 1/5. And we end up with 2 pi over 5. Tiny, tiny volume, 2 pi over 5, but we knew that because of how tiny our diagram was to begin with. Okay. Thank you very much for joining me on shells. We've got another type of volumes coming up on the next few pages.